Good afternoon. Welcome back. Now, the lesson surface areas and volumes. So, we have solved so many problems in the previous session. I am continuing the same because there are lots of problems on these surface areas and volumes, because the same chapter it will continue in the 10th standard also. So, you should learn the different types of problems here itself. Okay, and you should go through that the reference books what you are having. There are lots of problems are given. Work out that, because you have plenty of time to solve the problems. Okay, so solve all the problems which are given in the together with what the reference books given to you. Okay, now after this session I will wind up this chapter surface areas and volumes. If you have any doubts regarding any problem, you can call me instead of messaging. You just call me and tell the problems, what types of problems. If you have problems, you just write down and send the photocopy of the problem. I will solve and I will send you back. Clear? Now, next in this today's problem, I have taken this: the internal and external diameters of a hollow hemispherical vessel. Internal and external diameters of a hollow hemispherical vessel are 20 centimeter and 28 centimeter respectively. Find the cost of painting the vessel all over at 14 paise per square centimeter. So this is the problem. Now, how to solve this problem? So first you should know that vessel. So how the vessel is. Okay. Now first I will show you the vessel. It is a hemispherical bowl. So bowl, you know that you all having the bowl. Here in this there are two bowls like this. Clear this. This is the inner one and this is the outer one. So this is the bowl. Clear? Now here the internal and external diameters. See, this is the internal one. So its diameter is 10 and this is the external. I am writing outside. This is the external, that is 28. So here D1 is 10, D2 is 28. Clear? This is the diameters. Now to find the surface areas of a hemispherical or a sphere, we need the radius. Is it right? Because the formula is pi r square. Clear that? So first we should find out the radius. Now D1, that means internal, say Di, that is 20. Then I am taking that as R1 or I, that is 20 by 2, that is equal to 10. Internal radius is, internal hemisphere radius is 10. Then diameter of the external, that is 28. So RE, that is 28 by 2. 14 centimeter. Now we have the two radii. One is the internal radius and the external radius. Now they are asked what is the price or the cost to paint all over. So all over means it is a outside of this bowl. See, this is the outside bowl. We have to paint outside like this. And inner one is there, no? That also we should paint. Inner one, inner bowl. So like this. See, this is the inner bowl. We have to paint inside. Inside we have to paint that. So that is what? The inner painting. Clear? Then here is the part of this one. We should find out this also. Just assume that a coconut shell or a coconut. When you cut it and open, you have two parts. Is it right? That coconut is there, no? Inside that area, that is a smaller one. Then outside that area is bigger one. So just imagine that. Okay. Now, here we have to find out three things. One is this area, another one is inside of this area, and third one is this area. So we should find out the three areas of this bowl. Okay. Now, first external area. External area equals, what is that? 2 pi r square, because that is the curved surface area of the hemisphere. Curved surface area of the hemisphere is 2 pi r square. That is equal to, or you can write down this as 2 pi r square. Then internal area. This is external, and internal area is 2 pi ri square. That is also internal. So internal surface area is also 2 pi r square. Then area of this part, this internal and external part, we are removed that, no? So this, for example, see, this is the one. So outer circle and inner circle, we are removed this. Therefore, what we can take it as pi re square minus pi ri square. That is pi common re plus re square minus ri square. External radius minus internal radius, or if you can take a smaller one as small r and a bigger one as a capital R, you can do that. See, I have taken like this. Okay, now sum of the areas is equal to 2 pi re square plus 2 pi ri square plus pi into re square minus ri square. You can find out separately and then add, okay, to get the total surface area. So I am taken like this. In this, what I can write is, here is, take it pi as common, then left out is 2 into re square. That means radius of external hemisphere is 14 square plus 2 into 10 square plus, here is a re means 14 square minus 10 square. Are you clear this? Now this is 22 by 7 into 2 into 160 or 196 plus 2 into 100 plus, here is a 196 minus 100, only 96. Clear this? Now I am rubbing the problem. So are you followed? Just do once or twice, you will know that. Now this is 22 by 7 into, now 196 into 2. 2 6 are 12, 1, 2 9s are 18, 1 19, 1, 2 1s are 2 and 3 plus 100 into 2 is 200 plus 96. This is 22 by 7 into. Now add all these things. 6 plus 0 is 6 plus 2 is 8. 9 plus 0 is 9 plus 9 is 18. 1. 1 plus 2 is 3, 3 plus 3 is 6. 688 into 22 by 7. This is the total surface area of the bowl, hemispherical bowl. Are you understood? Now, here what they given, what is the cost? 14 paise per square centimeter. Okay, 14 paise per square centimeter. So, you should convert that into rupees. So, cost is equal to 688 into 22 by 7 into 14 by 100. 14 paise converted into rupees. So, I am divided by 100. So, on simplifying this. So, simplify this. I am not simplifying that. I am giving the answer. This is what? 302.72 rupees. 302.72. So this much money we need to paint the bowl. Clear? So this is how I am taken the whole thing. That means adding the surface areas. Okay, inner surface, outer surface, like that. Now, if you are not willing to do like this, then are you clear this? Now I am rubbing this. Clear? So total amount is this. This is the total surface area, square centimeter. Now you are multiplying this by 14 by 100. That gives 302 by 302 means 302 rupees 72 paise. Okay. Now I am doing in another way. I am showing you how to do that one. Now capital R, small r is 10, capital R is 14. 28 means 14. Now first one, area is 2 pi r square. That is 2 into pi. Keep the pi as it is, into r square is 14 square. That is 2 pi into 2 into 196. That is pi into 196 2s are 2 6 are 12, 1, 18 plus 1, 19, 1, 392 pi. Okay, this is 392 pi. This is the area of the outer hemisphere. The second one, 2 pi r square. That is 2 into pi into 10 square. That is pi into 2 into 100. That is equal to 200 pi. Now third one is what? Finding the area, pi r square minus pi r square. When you take a pi common, then r square is 14 square minus 10 square. Pi into 196 minus 100. So 100 means 96 pi. This is the third area. Now total surface area. Are you understood this? Separately, if you are finding the areas, it comes like this. Now total. So how much area? Total area is equal to 392 pi plus 200 pi plus 96 pi. So when you take the pi common or add this 200, 392, and this is 6 plus 2 is 8, 9 plus 9 is 18, 8, 1, 6. So this is the total surface area. You can do it like this. Then after that you multiply this by 14 by 100. So the same thing you will get 688 into 22 by 7. This is the pi value. Okay, because all have pi now, that's why just keep that one instead of doing again and again, keep the pi constant. And this is multiplied by 14 paise by 100 becomes rupees. So when you multiply this, you will get 302 rupees 72 paise. So in this way also you can do the problem. Clear? So this is a one way of solving the problem. The second question. How many spherical bullets can be made out of a solid cube of lead whose edge measures 44 centimeter, each bullet being 4 centimeter in diameter? Look at the question. How many spherical bullets can be made out of a solid cube of lead whose edge measures 44 centimeter, each bullet being 4 centimeter in diameter? So I told you that if you are converting one object into another object, what I told you that you should find out the volume of the objects. That means you should divide one volume object by another one. So this is based on the volume problem. Okay. Now what is given? You should write down that. Say they given that the cube. Okay. This is a cube. Right. See, here is a cube. Each edge is 44 centimeter. 44 centimeter. 44 centimeter. There is a huge cube is there. That is the lead cube whose edge is 44 centimeter. Now, this is converted into spherical bullets. That means we have to make a bullets. You know the bullets? You are seeing that the balls, ball bearing balls, that is called the bullets, right? Spherical bullets. If you are seeing the cycle ball bearing, a small one, and if you are seeing the bullet vehicle, its ball bearing is bigger than the cycle one. Even if it is a lorry and all, the ball bearing bullets are bigger than all these things. So it is different sizes. So we have to convert like this. That means first we should melt this. Melting of this, and then we have to pour that into the moldings of a spherical shape. So we have to convert how many bullets we can make by this cube. So this is the meaning of this problem. Clear? So first find out the volume of this cube and divide this volume by the volume of one spherical bullet. Volume of one spherical bullet. So first thing is what? Volume of cube is equal to, so you know that formula is a cube. Now each edge is 44, so it is a 44 cube. That means 44 into 44 into 44. So cubic centimeter. Right. This is the first thing. Then second thing is volume of one spherical bullet. One spherical bullet. That is, so spherical, sphere. So what is the volume of the sphere is 4 by 3 pi r cube. That is 4 by 3 pi. Here radius of this, here d is given. So diameter is 4 centimeter and radius is 2 centimeter. So this is 2 cube. Now what we have to do is we have to convert this. That means divide. Then number of spherical bullets. number of spherical bullets is equal to volume of cube by volume of one bullet. Clear? Volume of cube divided by volume of one bullet. Now, so what is the volume of cube is? 44 into 44 into 44. See, this is a 44 cube. So that's I am written that as 3 times. Then here is 4 by 3 into pi into 2 cube. 2 cube means 8. So now here is 44 into 44 into 44 whole divided by, this is 4, 3 goes to up, or you can write once again, into 22 by 7 into 8. Are you clear this? How to write down? See here, why I am not multiplied this 3 times? Because here calculations, it becomes tough. So keep it as it is, so that calculation is easy. Now, what you can do is, are you understood this? Now, I am rubbing the first part. So here the problem, I am rubbing this. Now, number of spherical bullets is equal to 44 into 44 into 44 into, I am shifting this 3 and 7 up, 3 into 7 whole divided by, so left out is 4 into 22 into 8. Now 22 ones are 22, 22 2s are 44. Now 2 ones are 2, 2 fours are 8. Now 4 ones are 4, 4 11s are. Again 4 ones are 4 11s are. So here this is 11 into 11, 121 into 7 3s are 21. Now 21 ones are 21, 2 carry, 21 2s are 42, plus 2 44, 4 carry, 21 ones are 21 plus 4 25. So how much spherical bullets can be formed? It is 2541 bullets we can make. 2041 bullets, right? Yes, so correct one. So this is a 2541. So are you understand this? First find out the volume of a cube, then find out the volume of one spherical bullet. Then next is to find the number of spherical bullets. What you can do is, number of spherical bullets is equal to volume of cube by volume of one bullet. That is, see, don't multiply the numbers, then substitute the values and simplify, we will get the number of bullets. So when you multiply, when you melt a cube and convert that into spherical bullets, so like this we can find out the problem. Clear? Now the next one is, a cylindrical metallic pipe is 14 centimeter long. The difference between the outside and inside is 44 centimeter square. The difference between the outside and inside area is 44 square centimeter. Area of difference between the outside and inside area is 44 square centimeter. If the pipe is made up of 99 cubic centimeter of metal. Find the outer and inner radii of the pipe. So read the question carefully. There are two parts. One is area part and another one is volume part they are given. So separate that parts. Okay. Now I will show you how to separate that. Solution. See here, the cylindrical metallic pipe is 14 centimeter long. So that is a H. H is equal to 14 centimeter. The difference between the outside and inside area. Outside and inside area. That is given by. This is the first part they given. The second part is given by 2 pi RH minus 2 pi RH is equal to 44. So this is the outside area and inside area. The difference between these two is given by 44 square centimeter. This is the first part. If the pipe is made up of 99 cubic centimeter metal, so 99 cubic centimeter metal means first we should find out the inner volume of inner and outer. So that is the third one. They given that volume. That means what is that? Pi r square h minus pi r square h is equal to how much that? 99. These are the things they are given. So look at that. A cylindrical metallic pipe is 14 centimeter long. So h is equal to 14. That means the height of the cylindrical pipe is 14 centimeter. The difference between the outside and inside area. So that is given by 2 pi RH minus 2 pi RH. That is equal to 44. So you know the pipe like this. So this is the pipe. Okay. Its inner and outside area they given that. The difference is given that 44 square centimeter. And one more thing they given that the volume they given. Okay. Now how to find out the radii of the pipe? Inner radii. That means here this is the outside one. That is capital R and inside one. That is small r. This is a H is given that 14 centimeter. Okay. Now how to proceed this? First make use of this and these two. So keep these two things as it is. So first one is. So first take this one. Second part. In this 2 pi and H is 14 given. You write down that R or 2 pi as common. Then RH 14R minus 14 small r equals 44. So you can take it 14 also common. 14 into 2, 28 pi into r minus r equals 44. Now 28 pi. So here is a 28 into 22 by 7 into r minus r equals 44. 7 ones are 7 fours are. Now r minus r equals 44 by 4 into 22. 22 ones are 22. 22 2s are 44. 2 ones are 2. 2 2s are 4. So I am writing here r minus r is 1 by 2. So take this as equation number 1. Clear? We have taken the difference of the area. Difference of the area like this. Formula we are used. We don't know the capital R and small r. So keep it as it is. So we got equation number 1. Now let us take the second one. That is the this third part, volume, that means pi h into r square minus r square, that is given by 99. Now this is 22 by 7, 22 by 7 into 14. Here this, you can write this as r plus r into r minus r. How I am written this? Based on the formula a square minus b square. A square minus b square formula is r plus r into r minus r. That is equal to 99. Then 7 ones are 7 twos are. So r plus r. Here is r minus r is given. That also you can write it as 22 into 2 into 1 by 2 r plus r. Here this r minus r value is 1 by 2. That is equal to 99. Now here these 2 get cancelled. Now r plus r, capital R plus small r equals 99 by 22. So 11 twos are 11 nines are. Clear? So r minus r. So take equation number 2. Now from 1 and 2, from 1 and 2, what is that? R plus r is equal to 9 by 2 and r minus r is equal to 1 by 2. So when you add, see equation, it becomes 2r equals, you are adding 9 by 2 and 1 by 2. See, I am rubbing here. Nine by 2 plus 1 by 2, that is equal to 9 plus 1 by 2. Taking LCM, and this is 10 by 2 is 5. Okay, so 2r is equal to 5. Then r, capital R is equal to 5 by 2. Capital R is equal to 5 by 2. Now that is equal to 1 by 2 centimeter. Capital R, that means radius of the outer cylinder is 2.5 centimeter. Now we want small r. Small r is equal to 9 by 2 minus capital R. Then small r is equal to 9 by 2 minus capital R is 5 by 2. That is 9 minus 5 by 2. 4 by 2 is 2. Clear this? See, I am explaining once again. Here they are given that the radius of the difference between the radius, that means outer curved surface area and inner curved surface area difference, they given that 44. So you should write down that as 2 pi RH minus 2 pi RH. Keep it as it is. So when the problem is given, you just note down how to write the formula instead of substituting the values. So always keep the variables or these things pi and r values. So you should take out common and you can cancel it at the end, last, instead of because when you should use like this, when the variables are repeated in 2 or 3 formulas, variables are repeated in 2 or 3 formulas, then you should keep it the variable as it is only. So according to that, see here h is given, you can take it as common like this, simplify, first you are getting this. So all these problems you may expect this in a multiple choice also in a competitive exam. So you should be sharp in solving the problems. Okay, see, after work out some 3 or 4 times, even 10 times, you have lots of time at home, right? So drill work this, read the question, write down what is given and write down what is to find out. So once you know that, then it is easy to do the problem. In 2 or 3 ways you can do that. Direct method or by splitting the formulas, you can do that one. So this is the one we are taken R minus R as equation number 1. Then taking the volume difference. So when you subtract the volume of outer cylinder from the inner cylinder, subtract the volume of inner cylinder from the outer cylinder, that gives the 99. That is the volume of the whole cylinder. So substitute this here. This is the one thing, R square minus R square. Split that into A square minus B square. A plus B into A minus B. So substituting that, we will get the second equation, R plus R as 9 by 2. Okay, here I am not written. Here just take down this. R plus R as 9 by 2 and R minus R as 1 by 2. On solving this simultaneous equation, these two get cancelled. R plus R is 2R. 9 by 2 plus 1 by 2 here is given. That is 5. So you write down that 5. So R is equal to 5 by 2. That means inner radius of the cylinder is 2.5 centimeter and outer radius is that one and inner radius is 9 by 2 and minus R. Subtracting 5 by 2 from 9 by 2, we will get 2 centimeter. Clear this? So this is the way of finding the combined one. So in a different ways, the surface areas and volumes. Clear this? So I will wind up this chapter here itself. Clear? The next week I am starting a new lesson. If you have any doubts in your reference book, you can write down in a paper and post that or put it in a WhatsApp group. I will answer it and I will send you back. Clear? Okay. So this is the surface areas and volumes. Very, very important chapter. You just drill work repeatedly. Clear?